All right, video 2 is on midpoints and bisectors. Those are going to be special types of segments. So we're still talking about segments here. So everything that we learned in the first video is going to come back up here. But we're going to add some different things, and we're going to add some special types of segments. So again, our important things: identify and define midpoint and bisector, label and mark midpoints and bisectors, set up equations, and solve for missing segments. So these last two things, very similar to the last video, but you're going to have some different rules to follow when you see these key vocabulary words. So let's just jump right into it. So midpoint, a point on a line segment that divides it into two equal parts. We can use the word equal, or you'll see later on this year, you'll see the word congruent come up a lot. That means that these two segments are equal, or two things are going to be the same length or the same measurement, depending on what we're working with. So now, the picture and example. A is the midpoint of CD. If you remember from the last video, this stands for line segment. So we're going to have point C, and we're going to have point D. Now, A is going to go in such a spot that it creates two equal parts, or two congruent parts. And a lot of people think when they use the word midpoint, we think the middle. So that actually works out pretty well here. So we have C, A, D. Now, two equal parts. That means this part here is going to be equal to this part here. We use these marks to show when things are equal, again, or congruent. So the important thing that you get out of this picture is that C to A is congruent to A to D. This symbol here stands for congruent, right? That's what happens in a midpoint. So now when we go to do the algebra later, we know that these two segments are going to be equal to one another. Now, segment bisector, it's very, very similar. It does have one key difference. A segment bisector is a line segment, array, or a point that cuts a line segment into two equal parts. Again, the key thing here is two equal parts. The one thing that's going to look a little bit different. So again, if we have JO here, our line segment JO. With this being a segment bisector and not a midpoint, the middle of this line segment, what's going to go through here is not going to be just one point. So in this case, we have KE. So it's going to look a little different. It might look something like this. KE with the arrow on one side. Now, again, the same thing happens. This point here, K, is still in the middle. The only difference in the vocabulary word is it doesn't have to be just a point. It could be that this red line or this red ray is cutting line segment JO into, again, these two equal parts. So again, JK is going to be congruent to KO. Now, we only have two examples in this video, only two things for me to go through, one with a midpoint, one with a bisector. You just have to be careful when you get to the practice of what these questions look like. Try to pick out the midpoints, the bisectors, and then once we set up our algebra, it kind of works out the same as it did from the previous video. So we have here, example 1, O is the midpoint of DG. Now, when I look at this, the first thing that I want to do is I want to mark on my paper that I know O is in the middle, so I know that these two segments are going to be the same length. Now, I can go back through what we did in the last video. DO is going to be 6x minus 7, and then OG is going to be 5x plus 1. Now, notice how in this question, there is not a third piece of information. We don't know what DG is. Coincidentally, that's actually what the question is asking us for. Find the length of DG. So we are trying to figure out what this total length is. So we don't have an equation that we can set up where the two smaller sides add up to the third. What we're going to do instead is we're going to use that midpoint definition, and these marks over here that tell us 6x minus 7 is going to equal 5x plus 1. So our equation is going to be a little different here. We have 6x minus 7 equals 5x plus 1. Now, we're going to solve this using our algebra rules. Put a line down the middle. We're going to bring the 5x to the 6x and make sure that we do the opposite. We subtract from both sides. We're going to add the 7 to the 1. Kind of doing 2 steps in one here. If you have to do it separate, you can. We get x equals 8. Now, unfortunately, we are not done at x equals 8. This question asks us for the length of dg. So what we need to do, if you remember from the last video, we're going to take this 8 here and plug it in for these x's. So we're going to have 6 times 8 minus 7, and we're going to go 5 times 8 plus 1. They both come out to 41. This is a good way to check your work. You can plug the 8 into both, or you only need to plug the 8 into 1 because we know that they're the same. So they are both 41. And then to answer the question, what is the length of dg, the entire thing? It's going to be 41 times 2, or 41 plus 41, and we are going to get 82. All right. So again, very similar to the question from the first video, but again, make sure that you are paying attention to the vocabulary words and marking up your diagram right away. That's going to help you kind of figure things out quickly and be able to set up your equation. So now, last one, example 2. Again, looks a little weird. There's some extra things in this one. We have a couple line segments going on. We got a lot of points. So we're going to read this first and go from there. So the first thing I'm going to do, AC bisects XY at B. Now, which of these two gets cut into 2 equal parts? You might think it's pretty obvious because of where the B is. I mean, A to B and B to C do not look the same. The other thing that I like to think about in regards to the way this is written, my brain says AC cuts XY into parts. So XY is going to be the 2 pieces that get cut into equal parts. All right, so we know in this case that XB is equal to BY, not AB is equal to BC, and that's kind of clear on this picture. Sometimes it's not always very clear, so it's super important to make sure that you read and you know which one is getting cut in half and which one is doing the cutting. All right, so we'll label our information again. We're going to have XB is 2x plus 5, and let's see, YB or BY is 3x minus 9. Now again, we have these marks here. That tells us they're equal to each other, and we know it because we wrote it down before. So we have 2x plus 5 equals 3x minus 9. I'll put my line down the equal sign. I'm going to move my 2 to both sides, and I'm going to move my 9 to both sides. So we get 14 equals x. All right, that's one of our answers. It does say solve for x, so we've taken care of that. The last part says to solve for xy. Again, in order to find the length of this entire thing, we're going to have to plug in that 14 to the 2x plus 5 and the 3x minus 9. So again, 2 times 14 plus 5 and 3 times 14 minus 9. So they both come out to 33. And if we want the entire thing, add these together, our xy is going to be 66. All right, it's a little bit shorter of a video. The 2 key vocabulary words you need to know, midpoint and segment bisector. Make sure if you had trouble, watch this video again. Most important, make sure that you can mark and label over here. Mark and label which pieces are congruent, like we did here in example 1, and like we did here in example 2. All right, this is the part where you're going to stop. You're going to move on to your other packet. You're going to get those practice questions done. If you have any questions, you can ask your classmates. You can come up, you can see me, you can let me know. And then you'll get ready for that 5-point mastery check. All right, and then that'll lead us right into video 3. See you guys there.